The life cycle of a star ends dramatically. But first, the beginning. This is a molecular cloud. Innumerable nebulae like this exist throughout the universe. These clouds can be up to 100 light years across with as much material as 6 million solar masses of mostly hydrogen gas. This is the birthplace of stars. The molecules in this cloud attract each other, segmenting the nebula, and a protostar begins to form. As star density increases, so does the temperature at the core, eventually igniting hydrogen nuclear fusion reactions. This reaction produces deuterium and then eventually helium, forming a helium core surrounded by a hydrogen shell. Stars spend about 90% of their lifetimes going through this state, called the main sequence. With time, the inner helium shell burns hotter and contracts, causing the outer hydrogen shell to expand, eventually transforming the star into a red giant. If the mass of the star is less than 2.2 solar masses, a helium core flash occurs. The star now burns helium into carbon. Stars less than 8 solar masses become asymptotic giant branch stars, never quite achieving the internal temperatures to burn heavier elements, eventually burning down into a white dwarf star and, in theory, a black dwarf star. If a star has more than 8 solar masses, a series of core ignitions allows the star to fuse and produce heavier and heavier elements, burning neon, oxygen, silicon, and finally iron. Once a star achieves an iron core, it runs out of fuel and collapses under its own gravity, initiating a supernova, distributing the star's elements throughout the universe. At this point, if the core has a mass of less than 3 solar masses, the collapse of the core might be prevented by the pressure of the neutrons, creating a neutron star. Meanwhile, if the core has a mass of more than 3 solar masses, the star collapses into a singularity, forming a stellar black hole. Stars are the heart of the universe, acting as distribution centers for heavier elements. One day, our own sun will follow the same cycle, but luckily, none of us will be around to worry about